Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Picture this: you build an AI system that can think step by step, showing its reasoning before giving an answer. Sounds great, right? Because if the AI ever tries to do something suspicious, you can just read its chain of thought and catch it. But here's the big question researchers asked: what if the AI learns to hide what it's really thinking? In a recent paper titled Reasoning Models Struggle to Control Their Chains of Thought, researchers like Chen Yueh-Han and Tomek Korbak investigated exactly that question. And surprisingly, the results were not what many expected. Modern AI models often solve problems using something called chain of thought reasoning, or CoT. Instead of jumping straight to an answer, the model writes intermediate reasoning steps. Researchers use this to monitor AI behavior. If a model plans something harmful, its reasoning might reveal the intention. But this only works if the AI cannot easily manipulate or hide its reasoning. So the researchers asked, can reasoning models actually control what they write in their chain of thought? To study this, the researchers introduced a concept called controllability. This means, can a model deliberately change or restrict what appears in its reasoning? For example, imagine giving the AI a rule like solve the problem, but do not use the word chromosome in your reasoning. If the model follows that instruction perfectly, it means it has high court controllability. But the results were shocking. Across many models, including GPT-style models, Claude models, and open-weight systems, controllability was extremely low, sometimes as low as 0.1% success rate, while output formatting control was above 60%. In other words, AI can control its final answer, but struggles to control its own reasoning process. The paper even shows funny examples. In one test, the model was told, answer the question, but don't use the word XOR in your reasoning. The model started reasoning, then suddenly realized, wait, I already used the word XOR. And then it kept using it again and again. Another test required the model to write reasoning entirely in uppercase. It worked for a few words, then it immediately switched back to normal text. These failures show something interesting. The model isn't fully in control of how its reasoning unfolds. To measure this systematically, the researchers created a benchmark called CoT-Control. It includes over 14,000 test problems from datasets like MMLU Pro, GPQA, Humanities Last Exam, SWE Bench. Each task included special reasoning constraints. These constraints fall into three categories: information suppression, hide specific words or concepts, information addition, insert phrases like meow between words, style modification, write reasoning in uppercase or alternating case. These tasks simulate ways an AI might hide or manipulate its reasoning. Several surprising patterns emerged. First, bigger models control reasoning slightly better, but even the best models still struggle. Second, more reinforcement learning training actually reduces controllability. In other words, training models to reason better makes their reasoning harder to manipulate intentionally. Third novelty, longer reasoning chains make control even harder. The more steps the model takes, the less control it has over formatting or constraints. And interestingly, when models were told your reasoning is being monitored, controllability increased slightly but still remained low. This result is actually good news for AI safety researchers. Why? Because if models can't easily hide their reasoning, then monitoring chain of thought remains useful. It means hidden malicious plans might still show up in reasoning traces, but the researchers caution that we don't yet understand why controllability is low. It could be training objectives, reasoning architecture, or internal representations of thought. Future models might eventually learn to control reasoning better, which could reduce transparency. So, the big takeaway from this research is almost paradoxical. AI models are getting better at reasoning, but ironically, that reasoning might be hard for the models themselves to control. And that small weakness could actually be our window into understanding AI behavior. The researchers recommend that future AI labs start tracking controllability as models scale, because one day, the moment AI learns to hide its reasoning perfectly, we might lose one of the most powerful tools we have to keep it aligned. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.